All right, so y'all might have been wondering what that business was that I clicked a button there on and something started running. That's a screen recorder. So we are recording this lecture. I record all of my lectures, almost all of my lectures. And we'll talk about that a little bit later on down in this list of comments that I have. So the warning that I'll give you right now is that your voice might be picked up on the microphone. I think it's got a pretty low radius, and it should be picking up almost entirely just my voice. But just for legal reasons, I feel it necessary to point out that if you do ask a question or something, you could get recorded. This recording will go onto my YouTube channel. It could go viral. Right? You never know. So anyway, you've been warned. Okay, so welcome to Math 212. Quick comment to start. If you're thinking about the possibility of a math major or a math minor, great idea, by the way. A lot of merits. Right? Feel free to come talk to me if you are curious about any of that. But in particular, if you think it's likely that you might do a math major or minor, talk to me soon. Okay, so sorry, we seem to be out of chairs. So are you registered or are you a wait list? Wait list. Okay. All right. Sorry. So you're welcome to stand or sit or share a chair with somebody if you can talk them into it. Sorry. Yeah. Right. Okay. If you're possibly a math major, then it is important to come talk to me as soon as possible. Course selection this early on is actually really important in a math major, and very likely this might be the right course for you, but it might not, so let's just figure that out for sure first. Okay, all right. As far as Math 212 is concerned, I have a class website. You'll get to it by going to this link. I think I may have emailed it to you already, but just in case I didn't, this is that link, and you just right here where it says Math 212, just click on that, and that's the website for our section of Math 212 this term. So you'll see a bunch of stuff here. There's a bunch of discussion. Make sure to read all this stuff. This is a nice discussion here, I think. I'm biased, I wrote it. Called Recommendations Concerning Schedule. How you should spend your time. How to do well in this course. Right? And the big visual effect, I think, is look at all of these items. Right? There's a lot to do that you should kind of always be doing. This is roughly speaking an every day or every few days kind of a list. So make sure to read through this and think about, how are you incorporating that idea into your Math 212 strategy? Okay, bunch of other discussions, bunch of other links, some big ones that I will hit on. Notice my office hours. That's hopefully handy. By the way, I arranged my office hours to be right after class, because I figure you're all here anyway. Any time that I pick, someone's not going to be able to make it. That's an unavoidable problem, right? But I feel like with this strategy, we minimize that issue. Hopefully, fingers crossed. Other than, I guess I could do office at midnight. Everyone's available then, but I'm not. Okay, so there's some important links up here. This row, the course information section. This general policies. Read about the Duke Community Standard as it pertains to this course. Attendance policy, right? Calculators, where to get help. I have a short-term illness policy. There's a lot of details in here. You need to make sure to read all this stuff. There's some talk about the recordings. So make sure to read all of that page. General comments. This is just a bunch of advice, really. This page is enormous. This is basically an accumulation of as long as I've been teaching, which is, let's not count how long that is, but it's been a while. And I have experiences with students where students made a classic blunder, mistake that they should have been warned about. I make an entry on this page, right? And so there's a lot that's added up. So make sure to read all these. I think this is all really good advice. And then this page over here, exams, homework, and grading. There's a bunch of discussion about, how should you interpret exam questions? What do grades mean? This kind of thing. What's the policies on homeworks, right? So anything that's related to testing or graded items should be, mostly on this page, with one exception. How all of those grades will be combined into a course grade. We have a new system for Math 212. this term. Brand new system. It's on the Sakai page, the Sakai site. Not the one for just our section, but the Sakai site that all sections of Math 212 share. It's in the resources section. It's called something, I think it's called Grading System Spring 2019 or something like that. Right? So that is it's a very explicit system. The previous system of how we used to do grades, if you took Math 122L last term, there was estimates given out in advance, and but nothing on record, nothing set in stone, and grades were pretty much determined by the instructors having all of the information at the end of the semester, and with all things considered, combining it all and coming up with what they feel most accurately represents all those performances together. It's a great system, except for the fact that students don't get concrete feedback. Right. So this new system that we're doing this term in Math 212 is sort of the exact opposite. On every for every midterm, you will get a letter grade. That letter grade will count as part of a very simple averaging, weighted average formula as part of your course grade. Right. So it's extremely simple. All the details are on this document on the Sakai site. So please make sure to go there, download that document, read it carefully, and okay. Let's see. The course syllabus is on the course webpage, linked right here. This is a math department maintained page. You'll see right there the syllabus. The syllabus includes, you'll notice, a bunch of book exercises assigned for each section of the book. And as we proceed through the course, I'll be sending you emails, typically on Wednesdays, because homework will be due on Fridays, indicating what sections we've covered. So, for example, by a particular Wednesday, we may have covered sections 12.1 and 12.2, perhaps. Right? I will email and say 12.1 and 12.2, and you interpret from that the exercises listed on the syllabus for those sections are the ones that are due then on Friday. All right? Is everybody cool with that? All right. Alrighty. Okay. Let's see here. Let's go back to the additional homework problems also on that same page. There's a list of problems that are not in the book that we wanted to include as part of the course. So they're on a PDF document on that course webpage. Our schedule, the lecture schedule, right here on our class site. For every given day, you can see exactly what we're planning to have done by that day. So, for example, on January 30th, my hope is that we will be done through page 66 of my lecture notes. By the way, my lecture notes are on our class's Sakai page. So I encourage you to download those. I think having a printed copy is a really nice way to go about, it's good to be able to annotate in class. We'll talk about that more later. But, or if you want to annotate electronically, also fine. Note that the exams are listed here. So our first exam is scheduled Feb 6. Second exam, March 20th, etc. Note that the exams are in weeks 5, 10, and 15, which I think makes sense. Okay. Alrighty. A bunch of other stuff. I'm going to let y'all click around on this. One thing I'll go ahead and talk about since I'm here. The recordings. Again, we are recording right now. Right? And this recording, screen recorder that is, so it's a recording that it'll show everything that's on the screen, and it's recording all of the audio, pretty much my voice, right? You can find it on my YouTube channel, which is linked right here. So you go to that YouTube channel. I encourage you to subscribe. That's up to you. Click on there's a playlist for every course that I teach, right? So for spring 2019 Math 212. There's what's called a playlist, and on that playlist, all these recordings, I'll just throw them onto that playlist every day, right? So the way I encourage you to use those recordings, I am kind of getting ahead of myself here, but obviously you got to come to class, right? But then whatever you don't 100% get in class, which I assume will happen, right? Nobody just gets it all first time through, right? So whatever you maybe a little shaky on, pick up the notes, do some studying, read that part of the book, talk to some friends, go to the help room, come to my office hours, right? Try to look at it from different points of view and maybe learn a little bit extra, and then go back to the recording, listen to it again. See if it doesn't make a lot more sense. And stuff that might have just kind of, but little comments that you didn't get at all, might all of a sudden make sense, and they just learned something that you couldn't have learned. So this recording strategy, I think, is really, really wonderful. I so wish that this had existed when I was in college, because I am very painfully aware that there were things that I didn't get in my lectures, right, that I just don't get in this life, right? Because the guy said it. It was a brilliant comment, I'm sure, and I didn't understand it at the time, and oh well, there it goes, off into the ether, right? So anyway, I hope you all will take advantage of that. I think it's a really good resource. While we're here, exams and solutions, this link right here is every exam followed by solutions that I've ever given in this course. And this is getting awkwardly large, really, really illustrates how old I am. Right? So there's a lot of study material. I encourage you to use this as study material. Please don't just go straight to the solutions. I would encourage you to look at the blank exams. Right? Here's an old blank exam. Look at the question after we cover the material. Don't look at this right now. You would have no idea, right? But after we've covered the appropriate material, look at the question, think about it, give it an honest try, right? Try to do it on your own. Make an effort. And then, if you get it, or if you give up on it, or whatever, once you feel like this is what I can do on it, then go to the solutions, right? And see the answer. But don't just go straight to the answer. Alrighty. There's a bunch more exams and solutions here. These are also all mine. These are from when I've taught the course in the summer. These are a little bit different. In the summer, I usually use my own textbook that I wrote. It's a little bit different from the textbook that we're using for this course. Not terribly different, but it is a little bit different, right? So all of these exams, I put them in a separate folder because there are some slightly different focus. There's a couple of topics in here that aren't in this course, a little bit vice versa. Nevertheless, it's still, I think, pretty good study material, and I encourage you to use these as well, just with that disclaimer. Okay. All right, et cetera, et cetera. Let's see. Let's go back to the, here we are, right? Okay. So your first day reading assignment is to read that main page on our class website. Read the links in the course information section. It's a big reading assignment. There's a lot of stuff, but this is all important stuff that you need to know in this section of the course. A bunch of policies and stuff. And then now you don't have to go to and read in detail every link from every one of those pages. Click around, see what's there. You might find some of that stuff useful too. Right? So I encourage that. And then make sure that I say print here, whatever. I'm going to save it to your, iBooks or whatever. The syllabus, right, you're going to be referring to that a lot. That's where all the homework exercises are listed. The lecture schedule, it's got all the exam dates on it. It tells you what the plan is for the class for any given day. So anything that you're going to be referring to very regularly, you want to have those super handy. Okay, some resources that I want to make sure you all know about. It's cheesy, but I think an important point that you are your own first primary resource in this course. Point being, you got to make yourself do the work, right? You have to be your own sort of initiative and your own sort of motor, if you will, making sure that you're learning the material as thoroughly as you should. Obviously, I want to help, right? I want to be a resource too, right? But I can't make you do it. So I think it's important, just sort of philosophically, that you have to realize that you are the number one item there. The book, all multivariable, all math books are imperfect, pros and cons, right? But all things considered, this book's not bad. It's okay. I pretty much like it. So it's a good resource. I hope you'll take advantage of it. Spend time with it. Okay. My lecture notes. Again, hundreds of pages of lecture notes. That's going to be most of what you're going to see on the screen and what we're going to talk about in this course. It's going to be up here and on the recordings. On the Sakai site, and I hope will be a good resource for you in this course. Right? The notes, by the way, are not just a transcription of the book. That would be pointless. The notes are kind of my point of view, right? A little bit different. What I hope will be an additional, a good supplementary resource for you. So you can't choose one or the other. You can't just say, I'm just going to do just the book. My notes have a bunch of extra stuff, and vice versa. Okay. I encourage you to read both of these before you come to class. Pretty much what we're going to cover on a given day. If you walk into class, sit down to hear the lecture, already kind of having broad strokes, rough idea of what's going to happen, it really helps. Oh my gosh, it really helps, right? So you're not trying to figure out where is he going with all this? What is it? What is this? The very first definition that he writes down. What does that mean? And you're trying to digest this starter idea. I'm off talking about the next things, right? I'm doing things, working with that definition, that concept, and you're still trying to digest what it is. You're at a big disadvantage. If you've already digested the fundamentals, huge help. Okay. I encourage you to read it again after class. Again, don't expect you to understand everything in class. That's not the strategy here. Like some schools, I don't know, just go way back to elementary school where you learn in class, right? And then, they make you do a little homework, sure. But learning happens in class in elementary school. That's not really how it works in this class, right? Hopefully some learning will happen in class, right? But it is not expected that that's where it will all happen. Right? A lot of the learning will happen after class, doing the homeworks, general studying, right? That kind of thing. Watching the videos. So reading the book after class, I think is a great idea. By the way, some stuff I will just plain skip. There will be stuff in the book that I will not cover. Don't have time. This class moves really, really fast. I have to make tough decisions about, what's going to be the most valuable use of our time. And I just can't get it all done. Right? So, again, if you just come to class and say, I don't need to read the book, I'll just listen to the lectures, you're going to miss stuff. Okay. I hope I can be a good resource for you. Right? That's going to be mostly in class. You got to come to class to get that benefit. Right? Yeah, you can watch the recordings, but it's not the same, right? Okay. I'm a big believer in group work, so I hope you'll view your classmates as good resources as well, not necessarily just, Section 1, but all other Math 212 students. I'm a big believer in study groups. I encourage you to work on your homework in groups. I think it's a great way to learn. I did a lot of that in college. It's very helpful to me. I like to say it, I learned more. I did a second major in physics. I learned more physics from my classmates than I did from my instructors. I feel that's a fair statement. Right? It's a wonderful way to learn. Obviously my instructors laid the groundwork and then, anyway. But anyway, I'm a big believer and I hope you'll take advantage of that. Okay. By the way, feel free to raise your hand if you have any questions. I tend to go on and on. So you're very welcome to raise your hand if you have a comment or a question or anything like that. Okay, let's talk about expectations. There's 6 sub-bullets here you'll notice, and they're kind of all just different ways of coming at the same point. So this is going to be somewhat repetitive and somewhat sort of back and forth. But I want you to understand exactly what it is that we're expecting of you in this course. And it's not the same as in high school, where at least my high school, maybe yours was different. But pretty much a lot of high schools, you're expected to know how to execute certain algorithms, and you're expected to have memorized certain facts. And if you can do that, you're good. Right? And that's step 1 here. Right? Yeah, of course you have to know certain facts. Obviously, of course you need to know how to do certain algorithms. Of course, right? But much more than that. So, item number 2 here: you are expected to know what these things mean. Right? You're expected to understand why the algorithms work. what assumptions do those algorithms rely on? Right? What are the conditions? Right? Strategically, what's the point of view that led to the strategy in the first place? Right? There's a lot of perspective and concepts and ideas to understand about, what you could just boil down to, well, just an algorithm. When you see this, you do the following steps, and there's your answer. Okay, so we will require and expect you to understand the ideas. That's, by the way, when you're studying, again, just from experience in high school and earlier, a lot of students study with just kind of default that this is what you're supposed to be doing. You're supposed to be memorizing and executing, making sure that you can execute the processes. And please try to break that habit to whatever extent you might still have it. Search for the understanding. That's the thing that will that's the magic ingredient that makes it all work, that will help you solve the hard problems on our exams. If you don't really understand what's going on, it's not going to work out. Right? So item 3, which is not that different from 2, really, from a certain point of view, is we're going to expect you to apply the ideas, not the algorithms that you've memorized, but the ideas, the concepts, the strategies, the points of view to unfamiliar situations that you have not seen before. And now, this is not to say I'm going to give you an unfair question, right? I'm not going to teach a class on calculus and then give you topology questions on the exam. That's not what we're talking about, right? But I'm going to give you questions on the exam that are not just like the homework questions. They're going to be different. They will be, however, entirely accessible by the same ideas, right? If you have that understanding, if you understand those fundamental ideas, those same fundamental ideas will allow you to solve the unfamiliar situations. So unfamiliar sort of details, but exactly same sort of ideas underneath it all. All right. So heads up. Okay. Which, by the way, let's just skip down to here. That's why the exams are not just like the homework. This is a complaint that we get on course evaluations fairly often, and every time a student is, just outraged, but the exams were not like the homework. And I think to myself, well, of course. Didn't you hear me on the first day? Right? Of course they're not just like the homework. We're trying to test whether you understand things and can apply to unfamiliar situations. So, unfamiliar, not just like. Right? Everybody see the point there? Okay. I like to bring up Wolfram Alpha at a time like this. Is everybody familiar with Wolfram Alpha? If you're not, wolframalpha.com. It's kind of a search engine sort of thing, but it has some crazy capabilities, right? You can type in using pretty much English language. You can type in integral of sine of x cubed and hit return, and bam, it will interpret what you meant by that, write the integral, do the integral for you, right, and give you the answer, and then give you various plots and, other data related to the question you asked it. It's amazing. Right? So, okay, so why do I bring this up? So this relates to why I say it's not enough to memorize algorithms. So the point is, let's think about, what do you take out of this course? When you get out of this course and you want to go on, you want to apply to a graduate program in engineering or econ or whatever y'all are majoring in, and they say, tell me about your math ability. What can you do mathematically? And if what you can do is execute algorithms and regurgitate memorized facts, then you can't do anything that Wolfram Alpha can't do. Everybody see my point there? I think this is a kind of a horrifying point if you think about it, right? Mm-hmm. That means that, if you take the old, what I like to call the high school strategy, I know it's unfair to some high schools, but, broad strokes. Take the old high school strategy to learning math, of just memorizing stuff, then those students are just slow, unreliable, and expensive alternatives to a free website. Right? So Whoa. Okay, so I hope that's a good sort of persuader of why it's important to understand ideas and to be able to apply concepts to new situations, to new kinds of applications. Because Wolfram Alpha cannot do that, and never will. That's speculation on my part, but it certainly cannot do that now, right? So take this seriously, right? Okay. Here's another point. Sometimes students, in some form or another, will express that. Look, just show me how to do what I'm going to need to do. I'm going to be an engineer. Just show me how to do the math that I'm going to need to know as an engineer. We don't know, right? First of all, I don't know everything there is to know about all of engineering, right? Second of all, nobody knows what kinds of problems engineers are going to be dealing with in 5 years or 10 years, when those of you who are engineering majors are still going to be in engineering, right? So we don't really know, right? So all we can do is arm you with concepts and, big picture ideas. And if you understand, how in the past, in the, sort of the current context, look, here's this kind of a question, and we attack it with the following ideas. And if you look at it this way, see strategically the idea is to take this problem and turn it into this other kind of problem. And we give you these kind of big picture ideas, and you see how to look at a problem and break it down and solve it. Then strategically, you can use those same ideas in this yet to be determined, unknown future challenge that you're going to be faced with that I have no idea what it's going to be. Right. So anyway, I think that's a good. You can see how all these ideas are kind of in the same vein. On exams, again, with this in mind, right? We're looking for ideas. We're not looking for right answers. We want to make sure your process makes sense, right? That you're reasoning that the A leads to B, which actually does lead to C, etc. If you understand ideas, you can communicate ideas clearly. Right? This is what we're looking for, not just whether you get the right number answer in a box at the bottom of the page. Right? So now I want to make a big deal out of this. Some students are, surprised. Some students kind of feel like maybe this is just a show, kind of a speech. Bray likes to make himself feel better. Talking about how abstract the class is going to be. But we all know that math is about the number at the bottom, of the page. But now you come to the exam, please take this seriously. We are going to be looking for process and clarity of communication and the validity of your reasoning, etc. And if you have the right number at the bottom and your justification's poor, you won't be getting good credit on the question. So anyway, again, that's because we're looking for understanding. So anyway, keep that in mind. So show your work, right? But even more than that, make sure don't just write on the exams and homework as an assistance to yourself to keep you from having to do the problem in your head, right? That's not what showing your work means. Showing your work means pretend like you are communicating to someone remotely. Paper and pencil is the only means of communication you have with this person, and you want to explain to them how to solve the problem. That's the way to think about it. Okay. All right. So I think we made it through the first 5 here. So, everybody understands things to some extent or another. In Math 212, we're going to want you to understand things more than in, let's say, a Calc 2 class, certainly more than a high school class. But more in what sense? Tragically, there's no metric units for comprehension, right? So I can't say, yeah, you're at about a 1.4 right now. We need you up to about a 2.3, right? That there is no such thing. So the reason that that's super awkward is that, I can't quantify just how much more you're going to need to understand things than you have been to now, right? So, but I want you to accept the idea that comprehension is not a binary thing. It's not just that, oh, well, either you do or you don't understand it, right? So let's take, single variable integrals. Y'all feel like you understand single variable integrals? But you want to bet I know some things about single variable integrals that you might not, right? I understand single variable integrals, and I better, right? It's my job. But there is a lot of depth to understand about single variable calculus, and y'all have achieved, a certain amount of it. But there is more, right? And then, by the way, there's tremendous. Single variable calculus is tremendously deep if you really take it really seriously. It's a whole field in mathematics called analysis. Here's the danger. Everyone feels like, again, that has some idea of what it means to understand something. Let's think of, a bar in your mind that represents, here's how deeply I need to understand material, right? This bar gets implicitly set, let's say in high school. And, you first see an idea, your comprehension level is here, you sort of realize that's not good enough, then you learn a little bit, and you realize, okay, I'm starting to get it a little bit, but at some point you learn it to the point where you get a familiar level of satisfaction. And where that bar is, that gets set by, where does your grade end up being what you want your grade to be? Maybe an A. I don't know. And so, you study up to the point where you understand it well enough to get that A that you were looking for, and that psychologically sets a bar in your mind of what it means to understand something. And here's the problem. High school math sets a bar there. Duke math sets the bar here. Right? And so the problem, this is a terrible, terrible problem. Students learn the material until they get up to that familiar bar, and at this point they're like, okay, cool, I'm good. This feels right. And then they get to the test, and the test is at this level, and it does not go well. Right? Everybody see the problem? So we need to figure out, and this is, I don't know how to do this perfectly, but how to address in your own psychology, where is that bar, and how do you raise that bar of what it means to understand something. How do you know when you've raised your bar enough? The best ideas that I can give you, here's two ideas. One of them is you can look at my old exams, in particular look at the solutions. Right? So the kinds of questions that you see on my old exams, I'm going to expect you to be able to handle those kinds of questions. Right? Does everybody see what I'm talking about? And you're going to find that they are substantially harder than, like some of you, by the way, have had a high school multivariable calculus course. Right? These Math 212 at Duke is going to have substantially harder exams than I'm going to effectively say all high school multivariable calculus courses. Right? Looking at the old exams, looking at the solutions, look at the level of rigor and communication presented in the solutions. That's what we're looking for, and that's where your bar should be. Here's another thing, and this next one is purely psychological and non-precise. But if you want to know if your comprehension level is high enough on a given topic, here's a little game that you can play with yourself. Ask yourself the question, and by the way, be honest. This is just for your own benefit. Okay? Ask yourself the question: if I had to come up to the front of the class, right, and give a 15-minute presentation on a particular concept, how would I feel about that? Is that a horrifying nightmare concept? Or is that, oh gosh, I only get 15 minutes? Wow, I have to squeeze all this I understand about this idea. I got to figure out how to compact that down into a mere 15 minutes, right? So these are very different emotional reactions that you might have to that hypothetical prospect, right? And my opinion is that if you look at the idea of talking to a group of other students on a particular concept as being a horrifying, oh my gosh, I don't know, someone's going to ask me a question, I'm not going to know the answer, that's probably a clue that, well, you've got some learning left to do in that area, right? On the other hand, if the idea is, okay, well, I guess everybody's got a certain amount of fear of public speaking, but I think I could do that, and there's a lot I'd want to say, and I'd have to plan it out, but yeah, sure, I could totally do that, right? Then maybe that's a good sign. right? For whatever that might be worth. Okay. I don't think this is news to anybody, right? We have a rep around campus. It's a hard class. So the thing I want to make sure to emphasize, though, is that this course accelerates throughout the term. So, if you look at difficulty, difficulty is a function of time, right? It's about like that throughout the semester. So the danger is if you for the first few weeks are like, okay, I see where we're at here. This is okay. I see how this class works, and you do some bunch of time management, and you sort of break down your week of how you're going to dedicate your study time to various classes based on this. Well, that is going to be insufficient, as represented by this area later in the semester. Everybody see what I'm talking about? So there's 4 chapters, roughly speaking, that we cover in this class. Chapters 12, 13, 14, 15. You'll notice that on the syllabus. Chapter 12 is largely just kind of vector analysis. We're going to actually get to some actual math today. I'm pretty sure we'll make it. But it's vectors and stuff, and so it doesn't hardly have very much calculus in it at all. Challenging, though, in a different way, so don't underestimate Chapter 12. But 13 and 14 are where we start to do derivatives and integrals. And then Chapter 15, we do a lot of advanced things with derivatives and integrals in really surprising and geometrically challenging ways. So that's Chapter 15 is where it starts to really step up. So anyway, when you're planning out your term and your time management, please do keep this in mind. We've already talked about the lecture recording. I think it's a great way to study through the course. While you're doing a homework question, just a little stuck on something. Oh, yeah, he said something about this in class. Hey, go over to the recording. Watch that 5 minutes. Just click to that, forward to that point in the lecture and watch those 5 minutes or whatever of the recording. And that might be just what you need to help you with that homework question. Okay. We will be taking attendance in this class. We will not be using Sakai attendance quizzes per these 3 items here, but I'll just be doing it on paper. I'm not going to start now because exactly who is taking this class is not entirely determined. But once the class roster is set, somewhere along in there, I'll start checking off names on a list on paper. And it will count as part of your grade. I've forgotten. I need to send you all an email with the exact details of. I want to say it's either 3 or 5% of your grade that'll be attendance. I don't remember exactly which one. So anyway, this is at instructor discretion. Okay. Okay. Last thing, real quick. As I commented before, I'm a big believer in study groups. I think it's a great thing. Let me qualify that. I think everyone's cornerstone, foundational idea of strategy for study should be alone time with the material. I think that's got to be right. But as an additional study method, I'm a big fan of study groups, right? Homework groups, right, where you share ideas on how to solve problems, help each other as you go along. If you already have some acquaintances, friends, people you want to work with, right, cool. If you don't know anyone in the class and you don't know anyone else in your friend group that's taking Math 212 and you're just not sure how you would go about finding a study group, a service that I offer, this is ultra low tech, I will maintain a list. You just email me and say, I would like to join the study group email list, and I will add you to the list, and I'll just make sure that everybody that's on the list has contact information for everyone else on the list, and only people on the list will get the contact information for the people on the list. Right, so it's ultra low tech, but so I'm not going to pair you up or set times or nothing of that sort. Y'all handle your own logistics, right? But if you just want to be on the list, if you want to know other people who are on the hunt for a study group, email me, let me know. Okay. All right. So let's do some math. So the first thing we're going to talk about is a math problem about dominoes and arrays of square tiles. Has nothing to do with multivariable calculus, but I think this is a nice exercise, and I like to start with it because this is going to help me make a point that I think is a really important point, again, about how to do well in this course. So here's a hypothetical scenario. Suppose you have an 8 by 8 array of squares. Right? Note that these are little squares. Right? And suppose further that you have these 2 by 1 tiles. Like these. Oh, come on, that's the worst I've ever done. 2 by 1 tiles, and specifically, they will always cover exactly 2 contiguous squares. So you can't, you can't do something like that. Right? So you've got these tiles and this array of squares. Simple arithmetic makes it clear that if you have 32 2 by 1 tiles, that will allow you to cover all 64 squares strategically, unchallenging how to do that, right? Okay, here's where it gets interesting. Suppose we remove 2 of the squares and 1 of the tiles. Now, can you still cover the remaining 62 squares with the remaining 31 tiles? And then the area still works out, right? It's still 62 and 62, so that's fine. But can you actually do it, is the question. Okay, all right, so what you do is you start doing this. You take your tiles and you start laying them down in some seemingly, I don't know, you just kind of start going, and then eventually, let's not act, it's going to take too long, but as you start to lay down tiles, you will find that inadvertently somehow you have painted yourself into a corner, at which point you'll feel silly and you'll think, oh, well, why did I do that? I see what I did wrong there. Let me not make that mistake again, and then you'll take off a few tiles and you'll put down in a different way, and you'll get that corner filled just right, and everything seemingly just fine. And then as you complete the process, you will paint yourself into another corner. And then you're going to start to raise your eyebrow and think, hey, can this be done? Or am I just really bad at this game? Right? How do you know? It's a hard problem. Maybe we're just really bad at this game. Extended failure does not mean that it's not possible. We might be bad, right? So here's how you. Now, one thing that you could do, you could trial and error this, right? You could code up some, way of keeping track of which ones you've covered, and always place your next domino in the next square, whatever that means. Come up with a definition of that, and for each time you cover a square, there's sort of, I don't know, at least 2 different ways that you might arrange it vertically or horizontally. Come up with some strategy for how to automate this process, and then have the computer handle it with billions of trials. Billions, by the way. There's 31 tiles, each of which horizontal or vertical. 2 to the power of 31 is more than a billion. Okay. Here's what I like to call the creative solution. You'll notice I've gone to great pains to not say checkerboard, even though it was an 8 by 8 array of squares, right? But let's take this 8 by 8 array of squares and let's paint a checkerboard pattern on it in the usual way, right? And then you make the observation that every tile covers 2 squares of different color, right? That's the way checkerboard patterns work. Okay, so now I'm going to define a little formula here, this thing called I. I'll tell you why I call it I in a few minutes. This thing called I. However you might have your tiles arranged, there will be a certain number of black squares covered. There will be a certain number of white squares covered. This thing called I is the difference. It's B minus W. Okay. And note, I is, of course, always 0. Because the number of black squares covered is always equal to the number of white squares covered. Okay. All right, well, here's the thing. We removed these opposite corners here, which, by tracing along a diagonal, again, that's how checkerboard patterns work, are the same color. So we remove, I don't know, maybe remove 2 white, maybe remove 2 black, whatever, it doesn't matter. To cover all of the remaining squares, we would need for I to equal to either 2 or negative 2. Because we either have 32 black, 30 white, or 30 black, 32 white. The difference is either 2 or negative 2, but that difference can never be anything but 0. Contradiction, therefore it's not possible to cover the 62 squares. Everybody on board? Very clever solution. This is what I like to call a creative solution to the problem. And this is literally creative because the pattern, this checkerboard pattern, was not part of the question. We made that up. That is literally creative. We created that pattern. This formula I, that was key to making this argument work, was not part of the question. We made that up. We created that little structure on our own. Right? So this is literally creative. And not to mention, not just the pattern, not just this formula, but this idea, the actual argument itself, we made up. Right? So this is very literally a creative solution. It's kind of offensive to me that a lot of people talk about, creativity. No, that happens in the arts and the humanities, and math is not creative. Math is just doing intense arithmetic, right? Various forms of just more and more advanced crunching of numbers, right? Well, this is absolutely false, right? I refer you to my earlier conversation about ideas in the class, right? So this is literally very creative. No asterisk, right? A lot of people say, well, it's not really creative because it's not really artistic. But it's not artistic, but it is creative. Anyway, that's my own little personal thing. Here's another point, by the way. I think this is a useful thing for y'all to know about. This is kind of a cultural point, but I think it's a really good thing to know. This thing I, this formula up here, right? The reason I called it I is because this is something called an invariant. And invariants exist in a lot of places in math. It's a very, very powerful idea. Make some expression that no matter what else is done in other areas, no matter how you lay down the dominoes, whatever, lots of things may change. How are the dominoes arranged may change, but this one thing does not change. It's an invariant. Right? So, powerful idea. So here, the fact that the invariant is 0 allowed us to answer checkerboard problems. But there's lots of other kinds of invariants that, by virtue of their not being able to change, we can, in very similar ways, draw powerful conclusions. Lots of math is done with invariants. So, like I say, a little cultural point there. Okay. All right. Now, why do I talk about dominoes in this course? Again, there's not going to be any dominoes on the final exam or the midterms. Right. But it's an excuse for me to talk about what my expectations. Again, so what kinds of things am I going to expect you to be capable of on an exam? So hypothetically, imagine an exam question that says, here's an 8x8 array where opposite corners are removed. Is it possible to cover that with 31 dominoes? As an exam question, is that a hard question? And I would say, no, that's a trivial question. I already told you the answer. Right? This is a memorize and regurgitate problem. Everybody see that? Okay. As we go through this list of hypothetical questions, they're going to get harder and harder. So what if it's a 20 by 20? That's different. Whoa, it's not 8 by 8 anymore. How would you deal with this problem of a 20 by 20 board or a 750 by a 750 board? Can you adapt the argument there? Yeah, a lot of you can still make a checkerboard pattern. The dominoes will still cover one of each color. You can still define the invariant. The opposite corners are still the same color. Contradiction, everything goes through. It's no problem, right? So, nevertheless, this requires adapting a little bit. These variations of the question require a little bit more adaptation. Now they're not square boards. Now they're rectangles. Does the argument work? Well, you've got to go through the argument and think through, can I put a checkerboard pattern? Can I define the invariant? Are those opposite corners still the same color? You got to. So the point is, in order to be able to apply the idea of the 8x8 case to this, you've got to think through all of the key ideas that went into solving that problem, and check and make sure that the arguments do go through. Here's one, 75 by 150. Checkerboard pattern, yep. Dominoes, one of each. Invariant, sure. Opposite corners. Opposite colors now. This is a different kind of a hard exam question. So don't make the mistake of thinking that, in class, Bray talked about, there was a question with checkerboards and dominoes, and the answer worked the following way. Hey, here's a question on the exam about checkerboards and dominoes. He just wants me to write down all that same stuff. Not here, right? It doesn't work here. A question like this, its purpose is to test whether you understood the assumptions, the conditions on the argument well enough to realize when they don't apply. And that for a question like this, you've got to take a different strategy. And in fact, for this question, not only is the argument invalid, the answer is different. You remove opposite corners of this 75 by 150 board, you can cover the remaining with dominoes. Okay. Different again, these get harder and harder if you have a 100 by 100 board, but you remove non-opposite corners. Does it work? Does the argument work? If the argument doesn't work, how do you fix the argument? Is the answer to the question ultimately yes or no? A lot to think about there. We don't have time to go through all of these, but you can look at these on your own. What if I don't tell you which, but I just tell you that they're of different colors? Right, so then there's no invariant argument. The invariant argument does not show that you can't cover this arrangement, but does that mean that you necessarily can? No. Right? Just because your elimination argument fails doesn't mean really anything. It just means that your argument's bad. That's a hard problem. This is a legitimately hard problem. Give it a try. Think about it. Right? But it's very challenging. And this one's really hard. If you have a 300 by 300, but you change the shape of the tiles and you're removing 3 corners, that's a hard problem. I hope you'll give it a try, though. If you play with it, you can get an answer there, and feel free to bounce your attempt off of me if you'd like. Okay. All right. And so there's some discussions here about these questions. Okay. All right. So we are done with page 3 in the notes. We're already behind schedule. There's a lot of stuff that has to get said on the first day, and this is always the case. We always catch up eventually. Nothing to worry about. But anyway, we will pick up here and go forward on Friday. See y'all later. Have a good one.